Let's go over positional encoding from a transformer model. Positional encoding is a technique used to ensure that a language model, such as GPT, doesn't lose the order of words when processing natural language. This is important because the order in which words appear can change the meaning of a sentence. Let's take the sentence "I heard a dog bark loudly at a cat" from our previous example. Without positional encoding, if we simply tokenize this sentence and convert the tokens into embedding vectors, we might end up with a set of vectors that lose the sequence information. Positional encoding adds a positional vector to each word in order to keep track of the positions of the words. However, by adding positional encoding vectors to each word's embedding, we ensure that each position in the sentence is uniquely identified. The embedding for I would be modified by adding a positional vector corresponding to position 1, labeled I1. The embedding for heard would be altered by a vector for position 2, labeled heard2. The embedding for it would be updated with a vector for position 3, labeled A3, and reused with the same positional vector for its second occurrence. This process continues for each word, token in the sentence, with dog 4, bark 5, loudly 6, at 7, and cat 8, all receiving their unique positional encodings. As a result, the sentence "I heard a dog bark loudly at a cat" is represented not just by a sequence of vectors for its words, but by a sequence of vectors that are influenced by the position of each word in the sentence. This means that even if another sentence had the same words in a different order, its overall representation would be different because the positional encodings would differ, reflecting the different sequence of words. So that's an overview of positional encoding.